In this demonstration, we're going to show you how to import in a 3D component, transform that component in several different ways, and then create some basic tooling so that you can create a part on your CNC machine that looks exactly like what you see on screen right now. We'll begin by defining the area that we're going to import our 3D model into. This needs to be big enough to accommodate the model with some space around it to allow us to cut out the part. So let's go up and create a new file. This is going to be a single-sided job. Our width will be 10 inches. Our height will be 10 inches. And our thickness is going to be 0.75. We need to make sure that our units are set to inches. We're going to be zeroing off our material surface. And our XY datum will be in the bottom left-hand corner. Now when it comes to choosing our model resolution, we have three different settings. We have standard, high, and very high. Of course, using very high will give us a much better model, but the calculation time for our tooling will be much longer. So in this case, we're going to go ahead and choose standard, and then we're going to choose our appearance. We have lots of different options here, but for this particular job, we're going to choose Canadian Maple and then click OK. Our next step will be to import in a 3D model. So to do that, we're going to go to our modeling tab. We'll click that. And then we'll go up to the top, and under 3D model tools, we'll choose import a component or 3D model. Now this will allow us to navigate around your PC, any external devices you have, or a network drive, and find any 3D content that you would like to import in. In this case, we're going to choose the magnolia flower, and it has a file extension of .v3m, and we'll click open. Once the 3D component has been imported in, you will see in the 2D view a grayscale bitmap representation of that 3D component. Now in some cases it's easier to look at the 2D view and the 3D view at the same time while you're working with 3D components. And to do that, we're just going to go up to the top here and tile our windows vertically. Now you'll see that in the 3D view, part of our model is missing. We only see the part of the model that's in the white space in the 2D view or in our workspace. Now we can, in the 3D view, we can go ahead and take a look around and look at our model by rotating it, by zooming in and out, and by sliding the surface around by using your mouse. Now we're going to need to get this model into the center of our workspace. And to do that, we're going to use one of our drawing tools. And right here, we're going to choose to use Align Selected Objects. So if we click that, we're presented with all of our different alignment tools. And in this case, we want our flower to be aligned both on the X and the Y in the center of our job. So we can just go ahead and choose this option right here. When we click that, our 3D model is centered in our workspace. And you can see that represented in both the 2D and the 3D view. Now we can just go ahead and close that down. Now that we have the magnolia centered, let's go ahead and have a look at some of our transform options. So seeing as our magnolia is already selected, and you can see that because it's pink in the 3D view and it's dark in the 2D view, if we click it one more time, we'll be presented with some handles. And these handles are in the 2D view and also in the 3D view. So if we go ahead and click on the top one in the right corner, and drag towards our upper right, you'll see that the bitmap gets larger in that direction. And in the 3D view, our component is scaled up in that direction. Now again, we can also go ahead and use the handles in the 3D view and do exactly the same thing, and the opposite will happen. Now if we take a look at these dark blue handles, these are our rotation handles. When you hover over them in the 2D view, you'll get the little swirl icon, and if you click that, you can actually rotate that around, and that again is seen in the 3D view as well. And we can do that here. As you can see, that's a very dynamic way of manipulating your model. What you do in the 2D view is automatically updated in the 3D view, and whatever you do in the 3D view is automatically updated in the 2D view. It's much like manipulating a vector in the 2D view, except for you won't see your vectors in the 3D view. So let's just go ahead now and undo all those steps and get us back to the point where we were when we first imported in our 3D content. We can also be very precise when it comes to manipulating our 3D content. Over here in our Transform Objects section of our Drawing tab, we've got Set Size. So if I click that, we'll be presented with our Set Size options. We're going to choose a scale space of our job alignment box. Because we haven't actually rotated it, then the rotation bounds haven't changed any. We're going to set our anchor to the center. And then below that, we have the option of typing in specific numbers to scale our object with. In this case, we have link X and Y. So if we change one of these values, it'll automatically update the other. So to test that out, we can put 11 here, and we'll see that our height is actually dynamically changed for us. And then we can also have our auto scale Z change as well. So our Z height of our object will change based on our size parameters up here. So let's just hit apply, and you'll see that the magnolia has been scaled up in both the X and Y and also the Z or the shape height. That's a little bit too big because the only bits that we see are inside of our white space or our working surface of our job. Let's change that down to 9 now. Hit apply, and that looks much better. So let's just go ahead and close that down. Now we can also rotate our object. So with that magnolia selected, we can choose our center point or our rotation point. We're going to rotate this relative to the center point, and we're going to go ahead and just type in 5 degrees and click apply, and you'll see that our object has rotated 5 degrees. Let's close that down. Now we can also mirror our selected objects if we would like. So let's just go ahead and take a look at those options. We can choose to mirror this based on our rotation bounds, but we're going to leave that unselected for right now. We can mirror it top, bottom, left, and right. We can flip horizontally or vertically, or we can flip about a line. For right now, we're going to go ahead and just flip about our job center, and we're not going to create a mirrored copy, and we're going to flip horizontally. And you'll see in the 3D view and the 2D view that's updated for us. Let's just go ahead and close that down. One of the last things we're going to look at when it comes to transforming your objects is actually setting the shape height or your Z height of our component precisely. If we go over to our modeling tab, and then we go up to the wrench or spanner and we click that, we'll have the option of changing all of our component properties. The first thing we can do is change the name, or we can go ahead and change the combine mode of the component, and this will change how this component will interact with other components in our job. And for right now, we just have the one, so we can just leave it. Now our shape height, this is our Z height. We can change this a couple of different ways. We can use the slider, and you'll see that dynamically in the 3D view, it will change. Or we can type in a precise number if we'd like to. In this case, we're just going to type in 55 and then press our space bar, and then in the 3D view, that will be updated. Now that we have our 3D component looking the way we want it to be, then we can go ahead now and start to develop tooling. We can get access to our toolpath options by clicking this button right here. And as soon as we do that, on our right-hand side, our toolpath options will be exposed. Now, the first thing we need to do is to make sure that the physical setup of the material on our machine is correct, and we can go ahead and start to create tooling. To do that, we're going to click the Set button and review our material setup. The first option is to double check the thickness of our material. In this case, it's fine. We're going to make sure that we're going to start our tooling at the bottom left-hand corner, and that's the way it's set up here, which is perfect. We're going to zero off our material surface, and now we get to choose where our 3D model is going to be positioned inside of our material. Now, like most pieces of wood, the surface is rarely flat, so we should leave a slight gap of material above our actual model so that we won't get any flat spots. And to do that, we can go ahead and use this slider and position our 3D component, which is this lighter brown section of this 3D representation, somewhere inside of our material. Or we can also precisely put that in by just typing in a number. So in this case, we'll go with 0.05, and that will leave us a bit of a gap at the top, and then a gap of 0.15 underneath our component. Now we can go ahead and check and define our rapid Z-gap distances, and also our home and start position. And these are based on your machine and how your setup is. Please make sure and check these and make sure that they're set appropriate for your needs, avoiding any clamps and other obstructions that might be in the way. And in this case, these are fine for me, so I'm just going to go ahead and click OK. It's important to understand that when creating 3D tooling, that your toolpaths will be created based on what we see in our 3D view. And we call what we see in our 3D view the composite model. In this case, we only have one component in our component tree, but if we had several and they were all visible, then our 3D toolpaths would be created based on that. It doesn't matter which ones are selected. Like in this case, whether or not the magnolia is selected or not selected is irrelevant when it comes to creating our 3D tooling. It only is important if it's actually showing up in our 3D view. When cutting 3D components, typically you'd have two different 3D toolpaths. One would be a 3D roughing pass, and the next would be a 3D finishing pass. The 3D roughing pass uses a large cutter to remove a lot of material, and then the 3D finishing pass goes in with a smaller cutter and then exposes all of the finer details of your composite model. Let's start off by having a look at our 3D roughing toolpath setup. So we're going to go ahead and click that button, and you'll see that we have all of our rough machining toolpath options here for us. First thing we need to do is to select a tool, and right now I don't have any tool selected, so let's just go ahead and select a tool. When I click that, I'll be presented with my tool database, and this has all of the default tools that were installed when my software got installed. And I'm going to go ahead and select a 1/4 inch end mill, and I'm going to select all of the default options here by clicking select at the bottom. Now, if I wanted to temporarily edit any of those settings just for this toolpath, then I could go ahead and click edit and make those edits if I want to. In this case, I'm going to leave them just as they are. Next, I can choose my machining limit boundary. I'm going to go ahead and select my model boundary. And so what that will do is the software will go in and find the edge of my actual component or my composite model and only machine what's inside of that. I can set up a boundary offset, and what that will do is it'll actually allow my tool to go outside the model boundary a certain distance so that I can go ahead and clean up the edge of my model. In this case, or in every case, your model boundary typically would be the radius of your tool plus your machining allowance. And for our benefit here, I'm just going to put in a 1/4 inch, which is plenty. That's the diameter of my tool. I can now define my machining allowance, which is the skin of material that my roughing pass will leave behind, that my finishing tool will remove, and this will help alleviate the possibility of my roughing tool chipping away at any material that may be needed for our finished component. So we'll change that to be 0.3. And I can choose our strategy, either Z-level or 3D raster. Z-level strategy is like pocketing out different levels down through our material, leaving behind at a minimum our machining allowance, but possibly even more. And our 3D raster is almost like a semi-finish that will leave a skin of material behind. In this case, we're going to use our Z-level. We're going to profile on the last of each step down, so it'll clean up the edges of our roughing pass. We're going to go level by level. We're going to raster along the X. We're not going to use any ramp plunge moves, and we're going to go ahead and calculate that. Now, as soon as our software is done calculating that, you'll see that we're presented with our preview toolpaths, and we can see our toolpath represented in blue in our 3D view, and we can go ahead now and preview our selected toolpath, and you'll see how it's pocketing down. Now we have up here selected that our material should be steel bright. We can change that if we would like to be any of these different materials, and in our case we are going to select the Canadian maple. And we're also going to use the material color to color in our machined area. Now our 3D preview is very powerful. We can see any problems that may arise before we actually try and cut this on our machine. In this case, we can see that our tool actually goes outside of our material just slightly. And if this is a problem, we should fix it now before we move on to our next toolpath. And to fix it, we're going to go over to our 2D view, select the component, press F9 on our keyboard to center that, and then we can just simply go ahead and double click on our roughing pass and we can recalculate that. We can reset our preview, and then we can preview that visible toolpath again, and you'll see that we fixed that problem, and now our component falls within inside of our material boundaries. Now one last thing is I would like to change the name of this. I can do it a couple different ways. I can double click on the toolpath and I can change it right here. And typically I like to include in the tool that I'm using, so 0.25 inch end mill, and then I can just go ahead and calculate that again. Or I can right click on the toolpath and choose rename and then just rename it right here. I'll just off click that to unselect it, and then we can close down our preview. For our second 3D toolpath, we're going to need to create our 3D finishing path. So let's just go ahead and turn off our 3D roughing, and let's go up and select a 3D finishing toolpath. Now this will expose all of our 3D finishing toolpaths, and right now we don't have a tool selected, so let's just go ahead and select that. And we're going to choose a 1/8 inch ball nose, and all this looks great, and we'll select that. And again, if you wanted to make any temporary changes to this cutter, then you can go ahead and just into your edits and click there, and you can go ahead and review any of the temporary settings that we have access to and change those to be appropriate for this particular toolpath. For now, we're just going to click OK. And for a machining limit boundary, again, we're going to select model boundary. We're going to use a boundary offset, and like we had said in our roughing pass, it should be about the radius of our tool. In this case, it's a 1/8 inch, so we're going to put in 0.1, and that should be plenty to roll the cutter off the edge of our 3D component so that we get all the nice edges as well. And we're going to choose a machining strategy of a raster, not an offset, but a raster in this case. And it's going to raster back and forth, back and forth, back and forth. And our raster angle is going to be 0 degrees. And at this point, we may as well give it a name. So we'll put in dash 0.125, and we'll calculate that. And because it's a much smaller tool, if we zoom in on our 3D preview, you'll see that our blue lines that show the path that our tool is going to travel are much more dense because it's a much small cutter. And we'll zoom out and let's preview that visible toolpath. And again, we'll take a look at our preview and make sure it's what we'd like to see in our finished part. And if we're happy with the amount of detail that we see, then we can just go ahead and move on to our next step. And I'm happy with that. So let's close down our preview. And our last toolpath will be a 2D toolpath, and we call that a profile cut. And that will actually cut our part out of our material. So let's go ahead and select that. And our start depth is going to be 0, so right at our material surface. Our cut depth is going to be the thickness of our material, which in this case is 0.75. We need to select a tool, so let's just go ahead and select one. And we're going to use our 1/4 inch end mill that we used before. And we'll click select. And then for a profile cut, we need a vector to actually profile around. We can't profile around a component boundary. So we'll need to go ahead back to our 2D options for a moment. So we'll click switch to design commands. And with our magnolia selected, we can go ahead and have the software create a vector boundary for us. So let's select that. And you'll see that if we off click in this white space, our flower, that our software has fitted a 2D vector all the way around our component, and we can use that now to profile out our part. So let's flip back again. And with that selected, we can go ahead and tell our software how we would like to machine around that, either on the outside of the line, on the inside of the line, or right on the line itself. In this case, we want to be outside. We don't want to use any ramp, plunge moves, or any tabs for this, but if you needed tabs to hold your part in place while you finish it off, this is where you would set those up. And we're going to go ahead now and give this a name. We'll call it Profile 0.25 end mill, and we'll calculate that. And you'll see again in our 3D view that we have our profile pass showing up, and we can see how many steps it's going to take for it to step down through our material. And we'll preview our visible toolpath. And that's exactly what we want to see. If we maximize our 3D view, we can take a really close look at our 3D preview. And again, take advantage of the power of this. If you see any issues at all, you might want to go in now and correct those by adjusting your tooling. If you're happy with this, you can double click on your waste material. Because we didn't tab it in, then it's free floating, and we can double click on that and our software will remove it for us. And if we wanted to send off a picture to our customer for them to approve, we can just go up to View and go down to Save Shaded Image and save it somewhere on our computer where we can find it, and we can send it off to our customer. If we're happy with this though, now we can go ahead and save off our toolpaths. Okay, let's close down our Preview Toolpaths form and go ahead and select our Save Toolpaths icon. We're going to make sure that we have unselected output all visible toolpaths to one file, and we're going to select one of our toolpaths, starting typically with the first one. You'll see that it'll be indicated here. And as long as you're happy with what's showing here, then we will go ahead and choose a post processor. Now, a post processor will take our code and format it in a way that your controller will understand it and your CNC will move properly. So you can just go ahead and take a look for your machine inside this drop-down list. But for us, we're just going to choose the G-code one. And then we're going to click Save Toolpaths. You can give it a name and save it somewhere so you can find it on your PC. And you'll do that for all of these one at a time. And now that you have your post selected, you won't have to select it again. Just save your toolpaths off, and away you go. From here, you may want to save off your file in case later on you might want to make some changes to it. And to do that, you just go up to File, Save As, give your file a name, and then click Save. Now this concludes this particular demonstration. I hope you enjoyed it.